So we're moving into large autonomous ships. We are going to build what we're calling Port Alpha, the shipyard of the future.
You ever hear about a naval base? That doesn't look like a naval base. The U.S. is quietly building hundreds of them, hidden in plain sight deep in Texas. Just machines, engineered for war.
This might look like a normal boat, but it is actually a drone boat.
If you're wondering how America plans to counter China's shipbuilding juggernaut, this is it, but no one's talking about it. Not yet. Today, we uncover the secret fueling a new kind of naval arms race. The secret base built for speed. In Austin, Texas, a classified facility is taking shape. Fast. It doesn't look like a naval base. But what's happening inside is sending shockwaves across the Pacific. It's called Port Alpha, a next-generation shipyard built to mass-produce robot warships. Fully autonomous, uncrewed, mission-ready. This is not a retrofit of an old Navy yard. This is a new kind of weapons factory. One designed to build vessels not in years, but in months or even weeks. And the country leading this charge isn't China. It's the United States. Behind Port Alpha is Saronic Technologies, a defense startup that has moved with unusual speed. Since 2022, it has scaled from a small engineering team to a 420,000 square foot facility, raised nearly $1 billion, and delivered 3 robotic ship models, Spyglass, Cutlass, and Corsair, from concept to sea trials in under 6 months. These aren't lab demos. These are operational autonomous vessels built to be deployed at scale. Why now? Because America is running out of time. China's shipbuilding capacity is unmatched. Its shipyards produce over 50% of the world's naval and commercial tonnage, more than 200 times the output of the U.S. The People's Liberation Army Navy now fields more ships than the U.S. Navy, and that gap continues to grow. American military planners have watched China outbuild the U.S. year after year. They know traditional methods won't catch up. The cost, complexity, and time required to build manned warships, aircraft carriers, destroyers, submarines are no longer viable on their own. So, the Navy is shifting strategy. Fewer exquisite ships, more autonomous ones. A hybrid fleet of manned and unmanned vessels deployed across the world's oceans, working together in real time. That's where Port Alpha comes in. This facility is built for speed. It uses modern manufacturing systems, modular ship designs, and vertically integrated software and hardware teams to build at scale. It's part of a larger vision to flood the sea with smart, expendable, unmanned vessels that can scout, jam, deceive, and strike without risking human lives. And China knows it. Port Alpha's existence alone marks a major shift in naval power dynamics. Beijing has built its navy on speed and volume. Now the U.S. is answering with the same, but smarter, faster, and unmanned. The robots are coming. And they're not coming from a lab. They're coming off the line, and that line just started running. China's strategy, and why this terrifies them. For decades, the U.S. Navy dominated the seas. 11 carrier strike groups, unmatched firepower, global reach. But while America focused on perfecting a few highly capable ships, China took a different approach. Build fast, build many. Today, that strategy is working. The People's Liberation Army Navy is the largest in the world by number of ships. It surpassed the U.S. in total hull count 4 years ago, and its shipbuilding infrastructure is overwhelming. Chinese shipyards can produce over 23 million tons of shipping per year. The U.S. builds less than 100,000. This isn't just about military vessels. China's massive commercial shipbuilding industry subsidizes its military capacity. Civilian yards can be repurposed in wartime, giving Beijing strategic flexibility. And they're not just building patrol boats. China is launching modern destroyers, cruisers, and aircraft carriers at a pace the U.S. hasn't matched since World War II. To support its growing fleet, China is also building out layered maritime forces. Its Coast Guard is heavily armed and functions like a second navy. Thousands of fishing boats are equipped to act as maritime militias. Combined, these layers project Chinese power across the South China Sea and beyond. It's a three-tier system: Navy, Coast Guard, and irregular forces. The strategy is simple: overwhelm opponents with presence and persistence. Flood the area with so many ships that control becomes a numbers game. This has already changed the balance in contested regions like the Taiwan Strait and the Spratly Islands. That's why Port Alpha matters. China's advantage is scale. Saronic's robotic warships threaten to erase that edge by giving the US a way to match or exceed China's presence without building billion-dollar carriers. If the US can field hundreds of autonomous vessels quickly, it can flip the script. Small robotic ships can patrol, collect intelligence, jam enemy radar, or carry weapons. They're cheaper, faster to build, and easier to replace. A swarm of unmanned vessels can monitor contested waters, confuse enemy sensors, or serve as decoys for larger manned ships. And they don't need food, sleep, or pay. That terrifies China's military planners. Their anti-access strategy depends on slowing the US down, making forward operations too risky or too costly. But a distributed network of autonomous vessels doesn't behave like a traditional fleet. It's harder to detect, harder to disrupt, and harder to predict. A single destroyer is a target. A swarm of robotic ships is a problem. The US isn't trying to match China ship for ship. It's trying to outmaneuver them with software, sensors, and speed. China's lead in ship count is real. But if America can mass-produce smart warships, the balance shifts. The plan may still have the numbers, but it could lose the advantage. Why traditional shipbuilding failed. For most of the 20th century, the U.S. shipbuilding industry was a global powerhouse. It built the fleets that won wars and maintained maritime dominance for generations. But after the Cold War, priorities shifted. Starting in the early 1990s, defense spending was cut. Inflation adjusted, it dropped by 24%. But shipbuilding budgets were slashed by nearly twice that, 41%. Shipyards closed. Skilled labor left the industry. Production consolidated into a handful of large contractors, focused on building fewer, more complex warships. The maritime industrial base was hollowed out. That's how the U.S. fell behind. The Navy's strategy leaned on high-performance, high-cost platforms, aircraft carriers, nuclear submarines, and missile destroyers. But these ships take years to build and cost billions. The Ford-class carrier costs over $13 billion per unit. The Zumwalt-class destroyer was supposed to be a 32-ship program. Only 3 were built. The rest were canceled due to cost and complexity. Even when plans were approved, execution fell short. A decade's worth of fleet expansion goals consistently missed their targets. According to Congressional Budget Office and Navy data, the U.S. has failed to meet its own fleet size projections for over a decade. As of now, it still falls short of the congressionally mandated 355-ship battle force. Meanwhile, China invested. Its shipbuilding capacity grew exponentially. The People's Republic of China now produces more naval tonnage than every other country on Earth. Combined, their yards are larger, faster, and subsidized by commercial contracts that double as strategic assets. The U.S. has tried to respond. Programs like the Littoral Combat Ship were introduced to create faster, cheaper vessels. But the results were disappointing. The ships underperformed. Some were retired early. The technology didn't deliver, and the price tags kept climbing. The Navy's new generation of ships, like the DDG-X destroyer and the Columbia-class submarines, are still on the drawing board, or years from deployment. None are built for mass production. That's the strategic vulnerability. America's shipbuilding system is built for precision, not scale. It can produce some of the most advanced naval platforms in the world, but it can't do it quickly, affordably, or in volume. And in a conflict where presence and persistence matter, where enemy fleets can be overwhelmed by numbers alone, that becomes a liability. That's why autonomous warships are not just an innovation. They're a necessity. A scalable, low-cost vessel doesn't replace an aircraft carrier, but it can scout for it, protect it, or draw enemy fire away from it. It can patrol without putting lives at risk. It can be built in weeks, not years. And most importantly, it can be built at a pace China can't ignore. Changing the game. The U.S. Navy can't outbuild China. The gap is too wide, the timeline's too slow, and the budget's too constrained. So instead of playing the same game, the Navy is changing it. The new strategy is called Distributed Maritime Operations, or DMO. The concept is simple. Stop concentrating power in a few massive, vulnerable ships. Spread it out across a wide network of vessels, manned and unmanned, that operate together, share intelligence, and strike in coordination. Instead of one destroyer with 100 sailors, field 5 unmanned ships. Instead of a single $2 billion frigate carrying sensors, let a swarm of drones handle detection, jamming, and targeting. This makes the fleet more survivable, more flexible, and much harder to neutralize. The Navy has been testing the idea with real hardware for years. The first proof came from a DARPA project called Sea Hunter. In 2016, this 132-foot trimaran sailed from San Diego to Hawaii and back, completely autonomously. A robotic brain navigating thousands of miles of open ocean. Sea Hunter was built to track diesel-electric submarines, quiet, hard-to-find threats, but its impact was bigger. It showed that a robotic ship could safely operate across international waters, obey maritime traffic laws, and persist at sea for weeks without human intervention. More importantly, it did this at a fraction of the cost of a traditional destroyer. The next step was a vessel called USX-1 Defiant, part of DARPA's NOMARS program, short for No Manning Required Ship. This platform was designed from the keel up to be autonomous. At 180 feet long and 240 tons, Defiant is smaller than most warships, but it's built for endurance. It can operate in rough seas, carry modular payloads, and survive extended deployments without a single person on board. Together, Sea Hunter and Defiant proved a point. Autonomy at sea is real. But these ships are just the beginning. DMO depends on numbers. Hundreds of smaller, cheaper, faster ships that can operate independently or in sync. These vessels serve as pickets, decoys, scouts, and missile platforms. They jam enemy systems, detect targets, absorb incoming fire, and feed data to the rest of the fleet. Only after that swarm has engaged does the traditional force arrive. Aircraft carriers, destroyers, and submarines delivering the final blow with high-value weapons and human crews protected. This is not a replacement for traditional naval power, it's a force multiplier, and it's built for speed. America can't win a battle of mass, but it can win with intelligence, distribution, and a fleet that thinks together. The rise of crewless warships. Autonomous ships started as experiments. Prototypes like Sea Hunter proved that a robot could sail across oceans without human control. But early designs were still based on traditional ships, with bridges, hatches, and cockpits just in case someone had to step in. The next step was to remove the crew entirely, from the design, the systems, and the thinking. Enter USX-1 Defiant, the first ship built under DARPA's NOMARS program, short for No Manning Required Ship. This wasn't a conversion. It was designed from the start to operate with 0 people on board. Defiant is 180 feet long and weighs about 530,000 pounds. That's small by naval standards, but everything about it is optimized for unmanned operation. The deck is flat and open, built to carry modular payloads, containers full of sensors, drones, sonar gear, or weapon systems. These can be swapped out in hours, not days. It's a floating platform that can change missions overnight. Defiant doesn't need them. Removing the human element allowed engineers to make the ship lighter, simpler, and more efficient. It can operate in rough sea conditions and keep going without rest or resupply for weeks. The design also improves survivability. No crew means no life support systems to maintain, not any human error to worry about in combat. And if the ship is lost, there are no casualties, just hardware. That's more than a tactical benefit. It's a strategic shift. Crewless ships can take risks traditional vessels can't. They can be sent deep into contested zones. They can shadow enemy fleets. They can loiter near choke points for weeks, watching, listening, and relaying real-time data. They can act as decoys, jammers, or even floating missile launchers. And they can be built faster and cheaper than anything with a crew. This approach isn't limited to one prototype. The Navy, DARPA, and private firms like Saronic Technologies are all building toward a future where crewless vessels operate alongside traditional warships. The concept isn't just about autonomy, it's about modularity and scale. The goal is a fleet that adapts in real time. Need surveillance, load sensor modules, need logistics, swap in cargo containers, need firepower, add missiles. Without crew limitations, these ships can be lean, mission-focused, and constantly deployed. Defiant's early tests are already shaping doctrine. The Navy plans to incorporate the vessel into its experimental fleet. If successful, it could lead to a whole class of purpose-built unmanned platforms operating across the globe. The age of the crewless warship has arrived, not as a replacement, but as a new foundation for how fleets are designed, built, and deployed. The robotic armada, built to scale. Testing a prototype is one thing. Mass-producing a fleet is something else entirely. That's where most defense concepts stall. They work in isolation, but can't scale fast enough to meet real-world threats. Saronic Technologies is trying to break that pattern. Since its founding in 2022, the company has grown into one of the most aggressive players in the U.S. autonomous shipbuilding space. With nearly $1 billion in funding, over 300 personnel, and a massive 420,000 square foot facility in Austin, Texas, Saronic has gone from blueprint to open water in under 3 years. Its production strategy is based on modularity and volume. The idea isn't to build one perfect ship, it's to build a family of unmanned vessels, each optimized for specific missions, all running on a shared software and hardware backbone. These vessels are already here. Spyglass, just 6 feet long, is a compact drone boat that can be launched from a beach, a small vessel, or a larger mothership. Its job is to enter tight spaces, shallow water, harbors, and island chains, and gather intelligence. It's cheap, mobile, and disposable if needed. Next is the Cutlass, a 14-foot node that carries small radars and sensors. It can serve as an autonomous scout or network relay, forwarding data between units and spotting threats early. Then comes the Corsair, at 24 feet. This platform has true endurance, over 1,000 nautical miles on a single run. It can tow sonar to hunt submarines, serve as a decoy by mimicking larger ships, or even launch small drones or loitering munitions. The Mirage, a 40-foot platform, is where the silhouette begins to look like a traditional patrol ship. It's fast, over 35 knots, and can shadow enemy ships, perform escort duties, or hold picket lines for days at a time, relaying live intelligence to manned vessels. Cypher steps into the logistics role. At 60 feet long, it's built to haul standard 20-foot shipping containers. Those containers could hold anything: medical stations, drone repair labs, resupply kits, or munition pods. It's fast enough to run ahead of a fleet, drop supplies on a remote reef, and return before morning. At the top is the Marauder, 150 feet long and able to carry 40 tons of payload. It's an unmanned arsenal ship. Missiles, mines, or electronic warfare gear can be loaded into containers and deployed anywhere without risking a crew. Each vessel is modular, autonomous, and designed for bulk production. Together, they form a flexible, scalable robotic fleet aligned with the Navy's 2045 vision. 150 unmanned ships, fully integrated into a 523-ship force. The Kill Web: how smart fleets work together. One robotic ship is useful. A fleet of them is powerful. But the real breakthrough comes when those ships work together. Not as isolated units, but as a connected, autonomous network. That's the shift from a kill chain to a kill web. Traditionally, naval warfare followed a linear process. Detect a target, relay the data, assign a shooter, fire. That's the kill chain. But it's slow and fragile. Break one link, jam a signal, sink a sensor, and the entire operation collapses. The kill web replaces that with a dynamic, resilient mesh of interconnected platforms. Every ship, drone, satellite, and operator shares data in real time. The system can route around interference, reassign tasks, and complete missions even if part of the network is lost. Here's how it works. A small spyglass drone sneaks close to an enemy coastline. It picks up an unknown radar signal but can't identify it. That data is instantly passed to a Cutlass drone 50 miles away, which has better sensors. The Cutlass refines the signal and sends it to a Mirage, which confirms it's an anti-ship missile site. Within seconds, a Marauder over the horizon receives targeting coordinates and prepares a strike. This is made possible by advanced onboard AI, edge computing, and encrypted communications. Every unmanned vessel processes its own data and shares what matters. Instead of raw sensor feeds, it sends insights, confirmed targets, threat classifications, movement patterns. That reduces bandwidth needs and increases speed. The Navy calls this approach Project Overmatch. It's part of a broader push to integrate manned and unmanned assets into a seamless digital ecosystem. Ships, aircraft, submarines, satellites, and ground systems all speaking the same language. But even in this autonomous web, one rule remains clear: a human still pulls the trigger. U.S. doctrine requires that any lethal action, especially missile strikes, must be approved by a human operator. That person could be aboard a nearby ship, at a remote control center, or even at a command post across the world. The decision stays with them. The autonomy handles everything else. This ensures compliance with law and ethics, but it also creates a new challenge. Communications must be fast, secure, and unbreakable. In a future war, a lost signal could mean a missed opportunity or a catastrophic delay. The kill web is the nervous system of the future fleet. The hulls are important, but this is the real power: a thinking, sensing, reacting network that turns ships into nodes and data into decisions. China's countermoves, disrupting the robot fleet. The U.S. Navy's move toward autonomous warships hasn't gone unnoticed. China sees it for what it is: a direct threat to its current naval advantage. And it's already adapting. For years, the People's Liberation Army Navy relied on numbers. With unmatched shipbuilding speed, it flooded the seas with destroyers, frigates, and missile boats. But the U.S. robotic fleet changes the equation. It threatens to match Chinese presence with cheaper, smarter vessels deployed in swarms, without risking sailors or relying on massive budgets. Beijing's response focuses on one core idea: disruption. The first line of effort is electronic warfare. Unmanned systems rely on constant communication. GPS for navigation, data links for coordination, and satellite relays for command updates. China has invested heavily in jamming technology designed to break those connections. Jamming GPS can leave a robotic ship blind. Interfering with data links can isolate drones from the fleet. In a contested environment, even the most advanced autonomous ship is only as effective as its signal. The second threat is cyber intrusion. China has a sophisticated cyber program capable of targeting military networks, control systems, and embedded software. If an unmanned vessel is compromised, even temporarily, it could be misdirected, shut down, or used to collect intelligence on U.S. tactics. In a worst-case scenario, an enemy could spoof a command, turning a U.S. autonomous vessel into a liability. Protecting against that requires hardened encryption, constant software updates, and real-time human oversight. The third approach is counter-swarming. China is developing its own fleet of unmanned surface vessels. Some designs, like the Jerry USV, a 50-foot armed multi-mission drone ship, mirror U.S. platforms like the Sea Hunter. Chinese military exercises have also shown swarms of small boats operating together, suggesting that Beijing is preparing for robot-on-robot naval engagements. In a swarm versus swarm scenario, quantity still matters. If China can field hundreds of low-cost autonomous platforms, it could use them to overwhelm U.S. robotic fleets in key choke points, imposing delays, causing confusion, or simply exhausting American resources. This is not a one-sided arms race. It's a global shift toward automated naval warfare, and both sides are racing to outthink, outbuild, and outcode the other. China's goal is to deny U.S. forces freedom of movement, to complicate every American decision, to turn unmanned platforms from an asset into a risk. The Navy's challenge isn't just building smarter ships, it's building resilient, secure network systems that can survive jamming, cyber attack, and saturation. The robot fleet gives the U.S. a new edge. But if China can disrupt it, delay it, or outnumber it again, the advantage won't last. Shipyards need to be upgraded. Factories must be built. Software, AI, and cyber defenses require ongoing investment. At the same time, Congress is still funding the legacy fleet, carriers, submarines, frigates, and the personnel to operate them. This creates a direct conflict. Every dollar spent on autonomous ships is a dollar not spent on traditional platforms. Some lawmakers see unmanned ships as untested. Others fear they'll reduce the need for sailors, and therefore jobs. These budget fights can slow deployment by years. Finally, there's the legal and ethical problem. What happens if an autonomous ship makes a mistake? If it misidentifies a vessel and attacks a civilian ship, who's responsible? The programmer, the operator, the admiral? U.S. policy is clear. A human must make the decision to use lethal force. But in a future war, decisions may need to happen in milliseconds. Can a human stay in the loop at machine speed? And if not, are we prepared to let AI make life or death calls? None of these problems are unsolvable, but they're not small either. The robot fleet is ready, but the world it must operate in, the budgets, rules, tactics, and trust, is still catching up. The verdict: can the U.S. actually win this? After all the prototypes, shipyard investments, software breakthroughs, and strategic shifts, the U.S. Navy stands at a turning point. The robotic fleet is no longer hypothetical. Vessels like Sea Hunter, Nomad, Ranger, and Defiant have logged thousands of autonomous miles at sea. Companies like Saronic Technologies are building out large-scale production. The Navy has committed to integrating 150 unmanned ships into its 523-vessel force by 2045, nearly one-third of the future fleet. But this is still the beginning, and the outcome is far from guaranteed. On paper, the plan is bold. a distributed, scalable fleet of smart ships that can swarm, scout, jam, and strike, all without putting sailors in harm's way. These vessels are cheaper, faster to produce, and harder to track. They turn naval warfare from a contest of mass to a contest of adaptability. But turning that paper into steel is the real test. This isn't just a technological shift. It's an industrial revolution. The Navy must move from small-run prototypes to high-rate production. That means retooling shipyards, stabilizing supply chains, and training a new generation of engineers, operators, and planners who understand unmanned systems. That takes time, money, and political will. It also means rewriting doctrine, how fleets move, communicate, and fight. It means building trust in algorithms and autonomy. Sailors must learn to operate as remote coordinators and system managers, not just pilots and crew. Admirals must rethink tactics that have remained mostly unchanged since the Cold War. The Navy's record on major programs is mixed. High-profile failures like the Zumwalt destroyer and littoral combat ship still raise doubts. The risk is that the unmanned fleet becomes another slow-moving, over-budget initiative. Too ambitious to cancel, too broken to deliver. But there are reasons to believe this time could be different. The threat is real. China isn't slowing down. Its shipyards continue to launch warships at unmatched speed. Its investments in AI, autonomy, and counter-network warfare are growing. The pressure is on, and that urgency could drive the Navy to act faster and smarter than before. If the U.S. can scale production, integrate autonomous ships into real missions, and maintain control over software, logistics, and communications, the payoff is massive. A distributed fleet is harder to kill, easier to upgrade, cheaper to replace. And when it's powered by AI and connected through a kill web, it can operate at a speed human-led fleets simply can't match. This isn't about replacing the old Navy. It's about building a new layer, one that buys time, reduces risk, and extends reach. Victory won't come from one ship, it'll come from the fleet that can adapt fastest, and the race has already started. Thanks for watching. If you found this story as gripping as we did, don't forget to like, share, and subscribe. More untold stories are coming your way, and you won't want to miss them.